All right, let's jump right into this. Welcome to today's Explainer, where we're going to challenge some of your most deeply held assumptions about humanity's place in the universe. You know, for centuries, we've looked up at the stars and asked, is Earth special? But recently, a massive wave of incredible scientific discoveries is forcing us to fundamentally shift that paradigm. What we're actually seeing out there suggests that the conditions for life, complex chemistry, and maybe even civilization itself are way more common than we ever dared to imagine. So today, we're going to walk through a series of staggering recent discoveries beyond Earth. And honestly, by the end of this, you might realize we aren't exactly the unique, first-of-our-kind civilization we usually assume we are.
So think about this for a second. What if Earth just wasn't the first? Imagine a planet somewhere out there in the enormous, sprawling history of the cosmos. It goes through exactly what we're experiencing right now. It has oceans, life takes hold, intelligent beings emerge, cities grow, technology advances, and this civilization starts looking outward, toward the stars, just like us. But what if that entire civilization rose, lived out its story, and completely vanished long before humanity or even our planet ever existed? I know, it sounds straight out of science fiction, but as we're about to see, the hard data is telling us the universe has had more than enough time and space to run this exact experiment.
So let's dive into Act 1, Neighborhoods of Potential Worlds. We're going to look at the actual places in our cosmic backyard that are redefining where life could take hold.
7. Just 7. But that number absolutely shattered our previous expectations about planetary systems. Located about 40 light-years away from us, astronomers found exactly 7 known planets orbiting a single, small red dwarf star.
This is the famous TRAPPIST-1 system. And what's so astonishing isn't just that there are 7 planets, it's what they are. All 7 are roughly Earth-sized, and they're believed to be rocky worlds. Plus, several of them orbit right in or near that sweet spot, the habitable zone, where temperatures could potentially allow liquid water to pool, depending on their atmospheres. For basically all of human history, we only knew of one rocky planet with life, and we're standing on it. Now, we're looking at densely packed neighborhoods of potential worlds. The James Webb Space Telescope is actually staring at the system right now. If biology popped up on even one of these tightly packed planets, it proves life isn't just some miraculous Earth-only fluke.
And speaking of Webb, our whole definition of where life can survive is rapidly expanding. Have you heard of a Hycean world? If we travel roughly 120 light-years from Earth, we hit a planet called K218b. It's bigger than Earth, but it sits right in its star's habitable zone. Recently, the Webb telescope detected methane and carbon dioxide in its atmosphere, which is huge when you're looking for environments that might support life. Researchers think it could be a Hycean world, meaning a planet with a massive global ocean hidden beneath a thick hydrogen-rich atmosphere. They even caught a tantalizing hint of dimethyl sulfide. On Earth, that molecule is only produced by living things. Now, we don't know for sure if it actually has an ocean, but it brilliantly proves our strict definition of a habitable, Earth-like planet might be way too narrow. Okay, let me just pause here for a quick reality check. We have to be incredibly clear. We have not found aliens. There is zero confirmed evidence of extraterrestrial technology or biology. Not on K218b, not in TRAPPIST-1, nowhere. It is absolutely crucial to ground ourselves in the actual science here. We are finding profound possibilities, not confirmed little green aliens. But honestly, it's those very possibilities that are shifting our entire perspective. Because we're finding those possibilities in some totally unlikely habitats, even right here in our own solar system. Take Mars. Sure, today it's a freezing, hostile desert, but ancient Mars? It had liquid water, rivers, and lakes. NASA's Curiosity rover has literally found organic molecules preserved right there in the Martian mocks. Then you have moons like Jupiter's Europa and Saturn's Enceladus. These worlds are completely encased in a shell of ice, but beneath that ice, they likely harbor enormous, deep oceans. Enceladus is actually shooting plumes of ocean material right out into space. We wouldn't even need to drill through the ice to look for life. A probe could just fly right through the spray. Life on Earth has shown us it thrives in extreme darkness around deep-sea hydrothermal vents, completely cut off from the sun. So a hidden ocean on a frozen moon, that could be just as exciting for finding biology as an Earth-like planet. And the hits just keep coming because we're constantly finding planets in places we didn't expect. Recently, NASA reported that its test mission spotted a distant super-Jupiter. But what's really cool is how they found it. They used gravitational effects rather than the standard transit method the telescope was originally designed for. Why does that matter? Because it proves our current catalog of planets is fundamentally incomplete. Literally every time we invent a new way to look, we find worlds we couldn't see before. The universe is likely hiding countless habitable worlds just because our current tech isn't quite equipped to spot them yet.
Which perfectly sets up Act 2, the universal recipe.
We've talked about where life might be, but let's look at what the actual building blocks are made of.
I really want you to keep this phrase in mind. Organic does not mean alive. Scientists are finding organic molecules on meteorites, inside comets, and even just drifting in interstellar space. But it's vital to understand that the word organic in chemistry just means carbon compounds. It's raw chemistry. It is not confirmed biology. That being said, the fact that these compounds are just floating around out there changes everything about how we view the origins of life.
And here is why it's such a game changer. The cosmic recipe itself. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. These are the building blocks of life. And they aren't rare, Earth-exclusive ingredients. They're forged inside stars, blasted out by supernovae, and scattered all over the universe. Young planets don't have to somehow invent the complex chemistry of life from scratch. Comets and asteroids can just deliver these carbon molecules right to their doorstep. It totally destroys the idea that Earth has some magical, unique set of materials. The raw ingredients are everywhere. The chemistry is widespread.
Now, hold on to that thought as we move into Act 3, the abyss of deep time, because this is where things get genuinely a little unsettling.
Just think about the sheer, mind-boggling scale of cosmic time. Our Earth is about 4.5 billion years old, but the universe? The universe is roughly 13.8 billion years old. Compared to the cosmos, Earth is remarkably young. I mean, there were billions of years of star formation, galaxy evolution, and planetary history before our solar system was anything more than a cloud of dust. When you lay it out on a timeline, it really hits you. The universe forms, and then for billions of years, ancient stars and planets just lived and died. Only much, much later, 4.5 billion years ago, does Earth finally show up. So what exactly happened in that massive empty gap? Really think about it. An entire civilization could have evolved, built technology to travel their solar system, thrived for 10 million years, and then completely vanished because their star collapsed or their planet died. Millions more years pass, their cities turn to dust, and Earth wouldn't even exist yet. Just by looking at the timeline, you realize there's been an enormous amount of time for other civilizations to rise and fall long before we ever got here.
So a natural question is, why haven't we seen any signs of them? Well, it all comes down to the observation problem. Detecting alien atmospheres is incredibly, frustratingly difficult. Take that TRAPPIST-1 system again. The star at the center is wildly active. It's constantly throwing off stellar flares and star spots that completely scramble our ability to get a clean read on its planet's atmospheres. Add to that, these distant atmospheres are super faint, the planets only cross in front of their stars for very short windows, and our current instruments have hard limits on their sensitivity. Our failure to find alien life doesn't necessarily mean the universe is empty. It might just mean our technology is still too primitive to pick up the signal.
And that leads us right into Act 4, the new question. Because of all these discoveries, the scientific community is undergoing a massive shift in what we're actually looking for.
See, astronomers aren't out there scanning for a sci-fi spaceship zooming past a star. They're meticulously hunting for biosignatures and technosignatures. What does that mean? They're looking for highly unusual atmospheric chemistry, weird organic molecules, unexplainable energy sources, or subtle geological clues that prove biology or technology was once there. If a grand civilization died out a billion years ago, virtually every physical trace of them would be wiped clean. The universe would only remember them through incredibly subtle chemical or atmospheric echoes. That is the needle in the cosmic haystack we're trying to find. Which brings us to a profoundly humbling realization. Human civilization, it might simply be one tiny chapter in a much, much longer cosmic story. We exist in a universe with trillions of stars, billions of galaxies, countless planets hiding deep oceans, the exact right chemistry, and an unfathomable amount of time. The universe has been setting up the conditions for civilization for billions of years. If intelligence can emerge more than once, then we definitely aren't the beginning of the story. We're just one civilization on one totally normal rocky planet in a 14 billion-year-old universe that's been running this experiment long before we got here. So the ultimate takeaway we're left with is this one lingering question. Are we alone? When you stack up all these new discoveries, the densely packed planetary neighborhoods, the widespread chemical ingredients for life, and the staggering abyss of deep cosmic time, it forces you to look at the night sky in a completely different way. Somewhere out there, millions or maybe even billions of years ago, someone else might have looked up into their own night sky and wondered the exact same thing. Thanks for joining me on this explainer. Next time you go outside and look up at the stars, remember, you might not just be looking at empty space. You might be looking at a history book. Keep looking up.